Thank you for joining in my talk. My name is Mohit Sharma. I'm a mobile engineer for past 10 years, currently working with MongoDB as a developer advocate for it. Today, and in this talk, I'm gonna share my thoughts to emphasize on the fact that mobile applications are also vulnerable and needs a dedicated security testing. Before we deep dive into the actual topic, let's look at some numbers to understand the mobile app market and its impact. According to Statista, the current number of mobile smartphone mobiles in the world is somewhere equal to 6.3 billion, which is equal to approximately 81% of the world population. And this number is expected to increase to 7.5 billion by the end of 2026. That means every user will have at least one smartphone. Last year alone itself, 218 billion apps were downloaded from the Play Store, which collectively generated a revenue of close to 143 billion USD. When translated into per user expense, that comes down to 5.3 USD. This is a lot of money. And there are people who wants to take cut in this, which is clearly evident from the fact that all the major apps, be it Facebook, Instagram, WhatsApp, Google, are all exposed to some kind of vulnerabilities. And the most amazing fact to this is there was a vulnerability to Google app, which is by default installed on all the Android devices. With this, I think so. I would be able to highlight the point that security testing of mobile apps is equally important. So, how can we change the situation? In my opinion, the only way to change this situation is to make all these stakeholders aware of the potential risk and how to overcome them. Going forward, I'll be talking about the top 10 vulnerabilities for the mobile app highlighted by OSAP. There is another testing separate guide in the OSAP itself, which helps you understand how to do a secure mobile testing. But I won't be covering that today. So the first item on the list is improper platform usage, which tries to highlight the vulnerability arises when the user hasn't implemented the platform features correctly. These platform features could be keychain, Android intents, platform permissions, touch IDs, etc. Let's look at the one of the examples of Citrix work app, wherein improper implementation of touch ID has impacted or exposed a vulnerability in the mobile app. This is the mobile app which we were talking about. Boom. You are able to access your work mail without having a proper credentials. So how can we mitigate or how can we avoid these kind of issues? You can by using secure coding techniques, using the best practices suggested by the platform, like iOS, Android, Windows, etc. When you are developing your application features. Few of them, which I could say with respect to the Android, would be don't allow the backup for your application. Debuggable mode of the mobile app should be disabled when in production. You should be allowed always to install the application in the device internal memory itself or the default storage. You shouldn't try to gather as much permission as possible. Only access or request for permissions which are actually required for the application. The next one on the list is insecure data storage. As the name suggests, the attacker tries to exploit the data storage of the device itself. This could be local DB, external disk, application files, logs, etc. One of the examples which I could found for this vulnerability was Google Authenticator, wherein secrets were stored incorrectly into the SQLite database without using proper key store mechanism. To mitigate these kind of issues, always try to save minimalistic data. That is, only save the data which is required for the application for future purposes or for the current format. No, never try to oversave the data. If in case if in case you are deciding to save some data, always try to encrypt the data. Never save it in plain disk, so that even if it's exposed, it becomes a bit harder for people to understand what kind of data it is. Always review the information that is being logged. Sometimes our developer put logs to all the places, and this kind of exposes your business logic or even your username password. Let's move down to the next one. Insecure communication. In this type of vulnerability, the attacker tries to exploit the the data which is getting transferred across the wire. Wire doesn't specifically means the actual wire, it could be the wireless connection as well. One of the examples which I found for this was the MySafe smartwatch, wherein with this smartwatch, the eavesdroppers were actually able to exploit the conversation which is happening between the children's. They were able to track them instead of parents tracking. They were also able to track them. They were able to change the application's functionality. So by force, they were able to change the core functionalities of the application itself. So they were able to change geofencing, which will due to which parents might not receive the notification when their children have moved out of the location. To mitigate these kind of issues, don't try to override the default platform network settings. By default, Android and iOS doesn't allow you to have HTTP communication. Disable SSL pinning. Try to have try to use only certified CAs. When it comes to SSL connections, always try to evaluate um, uh, the connection quality. There are various tools available which can help you understand with that. Try to set up try to do a man in the middle attack using untrusted certificate. There are various tools which helps you do that. Try to intercept and see whether everything is working fine or not. Let's move down to the next one. Insecure authentication. This is related to authorization of the end user and bad session management. In the mobile app, the authentication is a bit uh, complicated because user has to be validated irrespective whether the device is online or offline. For this uh, particular example, we I've noticed that Grab and the Ola mobile app had this vulnerability. The security researchers, in case of Grab specifically, were able to bypass the two-factor authentication by brute forcing the four-digit code. Actually, there was no limit on how many times that code can be entered. So you can get gain or access to any account. You can write from here to there, modify payment methods, or even use the existing payment methods, create any orders, etc. To mitigate these kind of issues, authorization should be required whenever users accessing sensitive information. It could be in form of PIN or fingerprint. We should always have inactivity timeout so the application locks itself if it has been inactive for a while. In case a new fingerprint has been added and your application allow fingerprint authentication, temporarily disable the newly added fingerprint and ask user to enter PIN to enable that fingerprint. This will prevent the attacker to access the application. The next one is insufficient cryptography. In this type of vulnerability, the cryptography was not configured properly. Or I would say the developer might have used an outdated algorithm or written a vulnerable custom algorithm. Example for this is again Ola app. When this was scanned by a third party, they discovered how weak the cryptographic keys were. They discovered the key because they were able to understand which algorithm was used, which in turn was due to which they were able to understand what is the key and they were decode all the data. Not only that, they also understood that this key was used at multiple places. So they were even able to decrypt further data. Mitigation for this type of is always use the latest industry standards when you're trying to encrypt or decrypt data. You shouldn't use unsafe crypto primitives like MD5, SH1, Blowfish, ECB, etc. Always try to create different certificates and key pairs for different purposes. Don't try to use one for all. Try to rotate the keys and certificates if possible. I know in mobile applications this is fairly difficult, but you can achieve this by force updating the app over a regular period of time. The next one is insecure authorization. This category covers the issues related to authorization such as forced browsing, privilege escalations, insecure direct object reference vulnerabilities, etc. Example for this would be Viper Smart and Pandora. With Viper Smart app, a security researcher were actually able to get a full access to the app, which was actually used to, which was actually a remote smart car app. So basically, after it, the user was able to gain accesses, change the car location, change whatever data it's there, open car remotely, or even immobilize it. So that was a big risk. In my opinion, to mitigate these kind of issues, the only possible way would be do a extensive testing with various rules. Try to have code review and access review done by the developers over a regular period of time. The next one is code qualities. As the name suggests, it refers to the issues related to the code quality. This includes the vulnerabilities um, like buffer overflow, formatted string vulnerabilities, etc. One of the examples for this, which I could found, was the WhatsApp app. So WhatsApp engineers found that it was possible to create a buffer overflow by sending a specially crafted packet to the WhatsApp when making a call. This vulnerability was later used to install a spyware on the phone and was sold to an Israeli company called NSO Group. I think so. We are all aware of that issue. The next one on the list is code tampering. Code tampering consists of duplicating the application, adding one or several backdoors to the code by resigning it and publishing it to third parties stores, trying to appear as the genuine one. This has been also done a lot of number of times, that you could see a duplicate number of WhatsApp or Tinder applications available. So, in my opinion, to mitigate these kind of issues, um, the only possible things or you can try is not to allow apps to be installed or used on the rooted devices, because it further leads to code tampering and everything. The next one is reverse engineering. In this, basically the attacker tries to download the targeted app from the app store or from the store and tries to reverse engineer the logic and the files, trying to understand what is the business logic and how he can exploit it. Ways to mitigate is fairly simple and straightforward, is to obfuscate the code. Obfuscation is a process by which you randomize or you make difficult for any person to understand the logic which is written in the code. It also, you can also yeah, make changes while with the code, so that while decompilation all the files won't be accessible or won't be able to be decompiled properly. These are a few of the tools which I have used, help me understand how I can understand what are the risks of exposed to any mobile application. These are a few of the references which I have used for this presentation. Thank you. That's all from my side. Thank you for listening in me today patiently. I'll be happy to take any questions if you have.
Yes, Mohit. What is your preferred mobile application, testing toolkit, or framework?
For me, I'll probably go with the LinkedIn one. Okay, the one which I've shared in the slide, the core one, because that helps me the way of trying to find what are the basic stuff. Okay, and that's also very easy for any developer to move forward with it. So I'll probably recommend using that application just to get the basic sense of what is the basic vulnerabilities which are there in your application.
Okay, I think we got the answer there, Mohit. Thank you very much. Does anybody in the audience have a question? No, but thank you very much for your time, Mohit. See you soon.
Thank you.